This is the Chump 4-bit computer. Let's divide this circuit into 3 different parts. This is the clock/counting circuit that we explored in the last part of the project. Then the signal comes up to the program counter right here and goes into the next stage, which is the EEPROM. So this is the program EEPROM and this is the control EEPROM. And here is our ALU. Here is our multiplexer. Here's our accumulator. Here's our RAM. Here's our inverter. And here's our address register. Currently, the program being run on this Chump computer is to load a bunch of numbers and then add a bunch of numbers. And that is displayed on these green LEDs right here. Here are these program codes displayed on the bar graph. Here are the control codes displayed on the bar graph. And here the red LEDs are the output of the multiplexer. As you may have noticed, there is no power coming from the top of my Chump board over here. So I actually soldered wires to the bottom of the breadboard that are connected underneath this Chump base plate, and they come out the bottom onto another breadboard here, which is feeding 5 volts from the DC jack. There are 2 types of EEPROM used in this project. The AT28C16 EEPROM chip is utilized for 2 purposes in this project: the program EEPROM and the control EEPROM. It has 24 pins in total, and A0 to A10 are for the addresses, IO0 to IO7 for data inputs/outputs, WE for write enable, OE for output enable, and CE for chip enable. The program EEPROM is where your code is loaded onto. The control EEPROM then takes the code from the program EEPROM and splits it into 8 bits, a high and low nibble. The EEPROM programmer was created using this circuit diagram. The EEPROM programmer was created using a circuit diagram from Ben Eater. It uses 2 shift registers and a lot of assorted jumper wires. Shift registers are used because the Arduino Nano doesn't have enough pins to connect the EEPROM directly, so the shift registers split up the pins. To upload code to the EEPROM, it is first placed inside the EEPROM programmer, then plugged into the computer. The custom code is uploaded to the EEPROM by uploading this code to the Arduino Nano. Then we can verify that it worked by opening the serial monitor and checking that the EEPROM programming is done. The arithmetic logic unit, or ALU, has a total of 24 pins. There are 2 sets of 4 operand inputs and 4 function select inputs: a mode carry input, comparator output, and carry output. The chip can perform a 16-bit binary arithmetic operations. The operation is selected by the 4 select lines, S0 to S3, to perform basic load, addition, and subtraction functions. The LU needs the clock circuit program ROM, control ROM, accumulator, and multiplexer. For more advanced operations like multiply, divide, go to, and store to, the RAM, inverter, and the address register must be added to support the chip.